What happens when lithium reacts with silver nitrate? This is an example of a single replacement reaction. Single replacement chemical reactions are exactly what the title single replacement says they are. Single meaning one, and replacement meaning to replace means that in a single replacement reaction, one element is being replaced. Before we look at how to actually predict the products of a single replacement reaction, we need to first be able to identify a single replacement reaction in the first place based off the reactants that we are starting with. Single replacement reactions will always start with one element and one compound as reactants. The products will always be a different element and a different compound. We can use the generic equation A plus BC yields B plus AC to represent a single replacement reaction. A represents the element that you have as a reactant, while BC represents the compound you have as a reactant. B would then represent the different element that is formed as a product, and AC represents the different compound that is formed as a product. Here's an example of an actual single replacement reaction. In this example, I can see that I'm starting with the element Na and the compound Al2O3. Because I'm starting with one element and one compound, this is an example of a single replacement reaction. Na and Al2O3 are going to react to form Al and Na2O. Don't worry about how that happens. The main thing you need to focus on right now is understanding that you're starting with one element and one compound, and that's what makes this a single replacement reaction. Now that you know how to identify a single replacement reaction, let's talk about how to predict the products. In order to predict the products for a single replacement reaction, you have to use what we call an activity series. There are two different activity series that we will have to use, one for metals and one for halogens, and they are shown here below. If you need to, pause the video and write these down, or you could search for an activity series on Google to use. However, you're going to want to have these close by because we have to use these when predicting the products for single replacement reactions. The activity series shows the different elements ranked in order of increasing reactivity. As the arrows show you, the elements increase in reactivity as you go up the chart. So the elements at the top of the chart are more reactive than the elements at the bottom of the chart. The elements that are higher up will replace elements that are lower on the activity series. So if I compare sodium and aluminum, I can see that sodium is above aluminum. This means that sodium is able to replace aluminum in our single replacement reactions, but aluminum is not able to replace sodium. Let's look at some examples now so we can better understand how to use the activity series to predict the products of single replacement reactions. So for our first example, let's go back to the reaction that we started the video with, lithium plus AgNO3. I know this is a single replacement reaction because I'm starting with one element, lithium, and I'm starting with one compound, AgNO3. Once I can identify that this is a single replacement reaction, I need to then use my activity series. I've put the activity series over here on the right side that we can refer to. I need to find lithium and silver on the activity series. It's important to note that we are going to compare metal to metal. What I mean by this is that lithium is the element by itself and it is a metal, so I'm going to compare that to the metal in the compound, which would be silver. I always want to look and compare the metal element by itself to the metal in the compound. So I'm going to see where is lithium compared to silver. I see that lithium is above silver, which means that lithium is more reactive. This means that lithium is able to kick silver out and replace it. So when I look at predicting the products, I'm going to put silver by itself, and then I'm going to bond lithium and nitrate together. Remember, when we bond elements together, we must consider their charges. I know that lithium has a +1 charge, and the polyatomic ion nitrate, or NO3, has a -1 charge. If I'm canceling out these charges, I only need one of each, so I'm going to write the formula LiNO3. I don't need to go back and worry about balancing because, as you can see here, this equation is already balanced. In our next example, we will look at the reaction when Mg reacts with the compound CaBr2. Mg is the element and it is a metal, so I'm going to compare it to the metal in the compound, which is Ca. I look at my activity series and I can see that Mg is below Ca. This means that Mg is less reactive than Ca, so it is not able to kick Ca out. This means that nothing is going to happen. If Mg cannot replace Ca, that means Ca is going to stay bonded to Br. So what we do is we just put Nr, which means no reaction. So if I were to mix magnesium and CaBr2, nothing is going to happen. In our next example, we're going to look at the reaction when fluorine, or F2, reacts with francium bromide, FrBr. This one is going to be a little bit different than our other examples because now we are starting with a nonmetal or a halogen, fluorine. We need to then compare this to the halogen or the nonmetal in the compound, which is Br. So I'm going to use my activity series for halogens, which I've put over here off to the right. I'm going to compare where is fluorine compared to bromine. In my activity series, I can see that fluorine is above bromine, which means that fluorine is more reactive, so it is able to kick bromine out. So when I predict my products, I'm going to kick bromine out and leave it by itself. And then I'm going to bond francium and fluorine together. Francium has a +1 charge and fluorine has a -1 charge. So when I write the formula, I'm just going to write FrF. You need to go back and balance this equation, so that's why you see I've put a 2 in front of FrBr and a 2 in front of FrF. It is also important to remember that fluorine and bromine both need subscripts of 2 because they are diatomic elements. In our last example, we're going to look at the reaction when iodine, or I2, reacts with MgCl2. Iodine is a halogen, so we're going to still compare this to the halogen in the compound, which is chlorine. I can see that iodine is below chlorine, and this means that iodine is less reactive, so it is not able to kick chlorine out. When this happens, we're going to have no reaction. If you made it this far, thanks for watching, and make sure if you haven't already, hit that subscribe button. If you found this video interesting or you learned something new, here are a couple other videos that you might find helpful.